वेलकम माय डियर स्टूडेंट, हाउ आर यू। तो आज जो टॉपिक में हम डिस्कशन करेंगे वो है फोटो इलेक्ट्रिक इफेक्ट। एट फर्स्ट दिस चैप्टर इज वेरी इंपॉर्टेंट चैप्टर and a lot of things to understand. This chapter I divide into 3 to 4 lectures. In first lectures, today lectures, we show the photoelectric effect and its experimental outcome. Number 2 lectures, we shall cover Einstein photoelectric theory equation and the failure of classical electromagnetic theory. And the third part, we shall discuss with various numericals, MCQ and de Broglie hypothesis, what is matter wave, etc. So, without wasting time, we shall go with photoelectric effect. Now, what is photoelectric effect? Photoelectric effect is emission of electron from metal surface upon irradiation of light. In metal surface, the outer shell's electron, what is called free electron. Free means it does not free to leave out the metal surface, but it is free to move inside the metal. It move inside the metal. If this is metal surface, then the free electrons will move inside the metal. If this is every electron, then it is free to move inside the metal, but it does not come outside from the metal. Now, when an electron comes out from metal, an equally positive charge will created there. As a result, and barrier is created on the surface. As a result, a barrier is created on the surface which pull back the electron towards the metal. So, we have to give an additional energy to the electron to leap out from the metal. So, the minimum energy, minimum additional energy or simply energy given to an electron to leave out or comes out from metal surface is called work function. It is denoted by W. Sorry. The minimum energy given to an electron to leave out from metal surface is called work function. So, the unit of work function is in eV. What is eV? We know that when an electron goes through a path which potential is 1 volt, then the kinetic energy acquired by electron is said 1 eV. So, 1 eV is equal to E into V. E means the charge of electron, that is we know 1.6 10 to the power minus 9 coulomb into 1 volt. So, 1.6 into 10 to the power minus 19 joule. 1 eV equal to 1.6 into 10 to the power minus 19 joule. In many equation, it is found that when the energy is in joule and it is converted to eV, the term is divided by 1.6 multiplied by 10 to the power minus 19 factor. Now, what is the photoelectric effect? So, what is the photoelectric effect? If we consider that, we have to consider the experiment of some greatest scientist. At first, the experiment was done by Frank Hertz. Then the experiment was done by Hallwatch. And then the final experiment was done by Lenard. Lenard experiment is very important, Lenard's experiment. In a evacuated glass chamber, he put two electrodes. One is cathode C, one is cathode, and one is plate or anode. Then, upon irradiation of ultraviolet radiation, UV radiation, some electron comes out from cathode and goes to anode, and a current is given in the circuit, or a current is flows in the circuit. As soon as he stopped the UV radiation, no current will flow through this circuit. From this, he concluded that a negatively charged particle, because as the particle were attracted towards anode, and as we know that the charge of anode is potential of anode is positive. So, he said that he assumed that some negatively charged particles were moved from cathode to anode. As a result, a current flows in the circuit. As before 3 years of Lenard experiment, big scientist J.J. Thomson already discovered electron. So, he know that this particle is obviously electron. So, this phenomena was first experiment by this Watch, Lenard and Hertz. This is known as photoelectric effect. So, if we define photoelectric effect, so that is the, you can know that the process of emission of electron from a metal surface when light of sufficiently high frequency incident on it is called PE, that is photoelectric effect. The process of emission of electron from a metal surface when light of sufficiently high frequency incident on it. Lenard also noticed that when light of frequency is smaller than a certain value incident on the metal surface, it does not emit electron. So, this term sufficiently high frequency is written. The minimum frequency, below that frequency no photoelectron were emitted. The minimum frequency for which photoelectrons emitted or photocurrent is getting photocurrent is called cutoff or threshold frequency, is called cutoff or threshold frequency, and it is denoted as nu 0. The incident energy must be greater than nu 0. If the incident radiation frequency of incident radiation is nu, then it must be greater than nu 0 to get photoelectric current. Some metal which such as alkali metals, you know the name of alkali metals if you read the periodic table chapter in class 10, that is sodium, potassium, lithium, cesium, rubidium, these metals shows photoelectric effect in normal light, normal visible light. And some metals like magnesium, aluminium, zinc, cadmium shows photoelectric effect in ultraviolet radiation. Also, X-ray shows photoelectric effect. Also, X-ray shows photoelectric effect, which is known as Compton effect, which is not in our syllabus right now. Scatter of X-ray by electron is known as Compton effect, and the scattered X-rays wavelength is greater than its original wavelength. This is not included in our chapter. So, we can already know what is photoelectric effect and how these occur at high frequency, that is shorter wavelength light, and which metals shows photoelectric effect. Now, we go with experimental outcome. अगर आपको मेरी वीडियो अच्छा लगा तो प्लीज़ सब्सक्राइब माई चैनल to get more new videos which is very useful for your future examination. Now, experimental evidences. The experimental arrangement of photoelectric effect is like this. Cathode, anode, and here a quartz window, and ultraviolet radiation is coming through this. Sorry, and a high tension battery with a key is connected here, and cathode and anode, here a microammeter, and here a voltmeter is connected in the circuit. Then the cathode is here a potential divider is set up, potential divider. Therefore, the cathode is connected in the midpoint of the potential divider, in the midpoint of the potential divider. If this is C, then this is the midpoint of this divider, and the anode is connected in variable length of this potential divider to change the potential of anode. Anode cathode potential is fixed and anode potential is changed. It is sometimes positive to cathode and sometimes negative to cathode. So, this is the experimental procedure. This is high tension battery, if we say E, and this is key K, this is potential divider, and you know this is voltmeter, ammeter, anode, cathode, and ultraviolet radiation, and electron comes out from this, go into this direction. This is the basis experimental equipment or apparatus of photoelectric effect. Please draw this in your copy. In your examination, if the definition of photoelectric effect or the properties of photoelectric effect is said to be written, then you must be, if you have time in your hand, then you must be draw this picture in your copy. Now we go experimental evidences. At first, we go with intensity. We go with intensity of light. When potential difference and frequency of incident radiation is fixed, then intensity of light is proportional to photoelectric current. When potential difference and frequency is fixed, intensity of light is proportional to photoelectric current. Because intensity means intensity equal to number of photoelectron, number of photon, sorry, photoelectron no, number of photon increased per unit time, per unit area, number of photon increased per unit time. So, as only one photon eject only one photoelectron, so there is more intensity, means more number of photon strikes the metal surface, and as more number of photon strikes the metal surface, then it will eject more number of photoelectrons, and more number of photoelectron means more photo current. So, if we draw a graph along x axis, along y axis we put the intensity, and sorry, along y axis if we photocurrent I, and along this if we put intensity, then we can get a straight line. This is photocurrent, and if I put intensity along x axis, then we get a straight line, that is linearly proportional. So, photocurrent is depend on the intensity. I hope you understand the explanation. Number 2, we go with potential. At first we take positive potential. Whose potential? Anode potential, positive potential of anode with respect to cathode. What happened? When anode is kept at a positive potential with respect to cathode, then electrons, if this is cathode and this is anode, then if this anode is kept positive potential with respect to cathode, then as electrons are negatively charged particle, they will easily attract towards anode. They will easily attract towards anode. Now, this electron accumulated on anode. Now, when further electron comes to anode, it will repel this electron. This space where electrons are accumulated near the surface of anode is called space charge region. If we increase the potential of anode again, then the electrons are not repelled, they will attract by the anode and photocurrent increases. That is, if we increase the potential of anode, the space charge or the repulse of electron is negligible and the electron will go to the anode. As a result, we can get photocurrent. So, the positive potential of anode is directly proportional to the photocurrent. Now, if we get negative potential, okay, Here also incident happen when when the positive potential of anode is increased at a certain time, at a certain potential, at a certain potential, obviously positive potential, the number of electrons ejected or emit from cathode equal to number of electrons collected by anode or plate. So, when these two will be equal, that is the number of electrons emitted equal to number of electrons collected, then however be the increase in potential, current will not increase. Current will not increase. If we potential versus current for positive potential, we see that the current will be not increased after a certain potential. This current is known as saturation current. Saturation means maximum value of current. So, at a certain potential, above certain potential, no current is increased. This is known as saturation potential. Now, if we get negative potential anode kept at negative potential with respect to cathode, then what will happen? Now, if we take anode negative, then obviously electron will repulse by the anode. So, they repulse by the anode, therefore photocurrent decreases, and if we increase the negative potential, negative potential, photocurrent rapidly decreased and at a specific potential or certain negative potential, current becomes 0. This potential is known as stopping potential and it is denoted by V0. If we increase the negative potential of anode, photocurrent decreases at a certain value of negative potential it becomes 0. This potential is called stopping potential because it stops the electron from reaching the anode. At this time, the kinetic energy of photoelectron decreases and potential energy increases by EV0. If kinetic energy is written as half mv max square, it is must be equal to potential energy E into V0. In this case, we can get half mv square equal to EV0. Now, if we draw the picture for 3 different intensity, if we draw the picture for 3 different intensity, what we can get? Keeping frequency fixed, if we draw a graph in this anode potential V and photocurrent. If we take a stopping potential V0, three different curves will be occurred for three different intensity of light. This is I1, I2 and I3. I3 must be greater than I2 and I2 must be greater than I1. Therefore, if we keeping nu fixed, here nu is fixed, keeping frequency of light is fixed, if we increase the intensity, then the value of saturation current is increased. Value of saturation current is increased as the graph is go with the upper portion and current. So, the value of saturation current, if this is IS1, this is IS2, IS3, obviously IS3 is greater than IS2 and IS2 is greater than IS1. But this will happen in at the same stopping potential. So, stopping potential does not depend on the intensity of light. This is the main overcome of experimental evidences. Stopping potential does not depend on the intensity of light. And again, as stopping potential is equal to the kinetic energy of the incident radiation. So, we can write that the stopping potential as well as kinetic energy of photoelectron does not depends on intensity of light. That is, it is independent of intensity of light. Stopping potential and kinetic energy is independent of intensity of light. This is the another outcome of photoelectric effect. Number 3, we go with frequency. Effect of frequency. Here intensity is fixed. Here intensity is fixed. If we draw a graph for 3 stopping potential V01, V02 and V03 and adjust the intensity, that the saturation current is same, that is here this is value of saturation current. It is anode potential and photon current. So, intensity here is intensity fixed. For a fixed intensity, if we adjust it, that the saturation current is same for 3 different frequencies nu1, nu2 and nu3, where nu3 is greater than nu2 and nu2 is greater than nu1, then we say that if we increase the anode potential, photocurrent will also be increased, and below a certain frequency there is no photocurrent exist. Below a certain frequency there is no photocurrent exist. This frequency is called threshold frequency. This frequency is called threshold frequency, and frequency is dependent on the frequency of the incident light. Its photocurrent is depends on its frequency. Below a threshold frequency, no photocurrent will emit. And also, if we draw a graph between anode potential and frequency for two different metal A and metal B, if is metal A and this graph is metal B, with that we say that frequency and anode potential are linearly, frequency increases with anode potential, that is proportional to anode potential. Frequency is proportional to anode potential, and if we take it from the back side, this gives the value of work function of a given metal. So, from this experiment we can show that the photocurrent depends on the intensity of light, number 1. Number 2, stopping potential or kinetic energy is independent of intensity of light, and number 3, frequency increases, then stopping potential increases, and above a certain frequency photocurrent will increase, but above a below frequency no photocurrent is getting, or no photocurrent is flows through the circuit. This frequency is called threshold frequency. So, if we write it, what we can get? Number 1 is anode potential or stopping potential is independent of intensity of light, or incident radiation. So, incident radiation. Number 2, photocurrent is depend on intensity of incident radiation. Number 3, below certain frequency no photocurrent flows. This frequency is called cutoff or threshold frequency. And obviously, number 4 is photoelectric emission is an photoelectric process is an instantaneous phenomena process, that is the time interval of incident photon and emits electron is occurred at the time interval of 10 to the power minus 9 second, 1 nanosecond. That is, it can be taken as considered as instantaneous photon. There is no time lag between incident of photon and emitting of electrons. So, from today's lecture we can know what is work function, what is photoelectric effect and its experimental efficiencies. But this cannot be explained through wave theory of light. It can be explained by quantum theory or Einstein photoelectric equation. In the next video, we shall discuss in this chapter. If my video is helpful to you and you consider to get more video like this, please press the bell icon and subscribe my channel. Thank you for that day. Good night. Welcome my dear student. How are you and how your study is going on? So today I will discuss photoelectric effect, that is the chapter dual radiation of matter or wave particle duality or dual properties of wave. This part, these topics I completed into 3 to 4 lecture. One is the characteristics and experimental fact of photoelectric effect. Other is the failure of classical wave magnetic wave theory and Einstein relation, and another is, and the last part is the mathematical numericals and the de Broglie hypothesis. So today we shall start the first topic, photoelectric effect and its experimental evidences, that is in practical what we found by experiment. So let us start. What is photoelectric effect? Photoelectric এই ঘরে না